Okay, how do we find out what the mass percent is? Well, it can be done experimentally, or if we know the chemical formula, we can calculate the mass percent. So the mass percent of the element that you're interested in, the easiest way to calculate this is to find the mass of that element in 1 mole of the compound and divide by the mass of 1 mole of the compound. The percentage doesn't change when you increase the sample size. So you can choose any sample size you want. And so to do this, what we're doing is we're choosing to say, well, what about a mole? 1 mole of this, because it's easy. We can calculate the mass in grams of 1 mole, and we can calculate the mass in grams of an element in 1 mole of that compound. So here's the general formula for what we're doing. So acetic acid, HC2H3O2, is the active ingredient in vinegar. Calculate the mass percent composition of oxygen in acetic acid. Now this formula looks a little funny, right, because the H's are separated. This is the acidic hydrogen, and this H at the beginning tells us that this is an acid. When we cover up the H, C2H3O2, that is acetate ion. So acetate, we change the H to ic, and it becomes acetic acid. So what we want to do here, we want percent oxygen. So we want to find the grams of oxygen and divide by the grams of the whole thing. And then we're multiplying by 100%. So they didn't give us any numbers in the problem, right? We've been looking at, well, we read the words and we take the numbers out and then we look at those and decide what to do. There's no numbers here. We've got the formula though. And so what we're going to do is we're going to find the mass of oxygen in 1 mole of acetic acid and the mass of 1 mole of acetic acid. So we're going to choose 1 mole. So we need the mass of 1 mole of acetic acid. So here's HC2H3O2. Need the molar mass. So we've got 1 mole of hydrogen, and we've got, not 1, we have 2 moles of carbon. And then there's another 3 moles of hydrogen. You can combine those together and say there's 4 moles of hydrogen, because there is, or there are, but you don't have to. And 2 moles of oxygen, 16 grams. (1.008) plus 2 times 12.01 plus 3 times 1.008 plus 2 times 16 equals. So 60.052 grams of acetic acid. So that's the number we're going to put in the denominator. 60.052 grams of the compound. How many grams of oxygen are in the compound? 1 mole. 2 times 16. That's how much oxygen there is, right? If you write out the calculation for the molar mass, you'll kind of accidentally do the part that needs to go on top. So you can multiply it out, or you can write it in just like that. I'm just going to write it in like that. So that's the grams of oxygen in 1 mole of the whole thing. Any questions about how I got that? Times 100%. So we've got 2 times 16 divided by 60.052 times 100. And that's going to be, how many sig figs should I have? 4. Here the number of sig figs is going to depend on the number of sig figs you used in your molar masses. I chose to use 4. I could have used more. So I should have 4. 53.2871%. And then when I round up, because of that 7, I get 53.29%. Any questions? In one molecule, there are 2 oxygen atoms and 2 carbon atoms and 4 hydrogen atoms. And yet oxygen by mass is over half of an acetic acid molecule, because each oxygen atom weighs a lot more than the hydrogen, and it weighs more than the carbon. Any questions? Yes?
So as far as like the moles, I don't get how they're relevant in this problem because we're using grams to get everything.
That's a good question. How are moles relevant? Well, one of the things that throws students about a question like this is, here you're supposed to do a calculation, but it doesn't give you any numbers. And so just to make it easy, we say let's choose 1 mole of substance, because then we can calculate the mass of 1 mole of the compound, we can calculate the mass of 1 mole of oxygen in 1 mole of the compound, and so then we know where to get our numbers from. So we just chose. You could choose to do 1 molecule, but then you're going to end up with some really tiny numbers, or you'd have to do it in atomic mass units, which would also work. Any other questions or stretching? Any other questions?